Okay, you guys, this last part of the notes on slope fields talks about how to match a slope field with a solution curve. Okay, so keep in mind the part we just talked about was matching a slope field with a differential equation. But this time we're talking about matching a slope field with a solution curve. Okay, so the idea is now instead of looking at the individual segments, you're looking more at the big picture. You're thinking about what would the original function be, or in other words, what's the shape of the graph that you kind of see mapped out on the graph there. So on this one, notice it says the slope field from a particular differential equation is shown. So a slope field always represents a differential equation, but it shows the picture of the solution curve. So which of the following could be the specific solution to that differential equation? Okay, so again, we're looking at the solution, and notice the choices are not derivatives, but the choices are equations of the original function. So if you look at this one, I hope it's pretty obvious that this would look something like the graph of a logarithmic function. I mean, it obviously doesn't look like a parabola, which would be x squared. It's obviously not an exponential function, right, where it's going like this, or e to the negative x, exponential going this direction. It's obviously not a cosine graph. So the only option here is that it would be a natural log graph. So on this next one, the slope field is given at the right. Which statement is true for the solutions? So again, before I even read the choices, they're talking about the curve that's shown. Now, if you look at this particular slope field, hopefully you'll notice that there's really two different shapes represented, and it all just depends on what point they say that you want your curve to go through. So if, for example, I want a solution curve maybe that goes through the point, right here, I don't know, what is that, maybe 3, 2-ish? Well, the one that's going to go through there is going to look something like, if I follow the pieces, something like this. But if they say, hey, I want the solution curve maybe that goes through the point, I don't know, maybe over here somewhere, you can see that one is going to be heading off that direction. So it looks like two different curves depending on what point they want you to go through. So look at our choices here. It says for x less than 0, so that means when you look at the left side, right? So when I look at the left side of the y-axis, all solutions are decreasing. Well, if I'm looking over here in this part of the graph, all solutions are not decreasing. I mean, up here they're increasing, right? If it's down here, yeah, they're decreasing. But that one is definitely not true. Okay, so we'll say that one is false. The next one, all solutions level off near the x-axis. All solutions level off near the x-axis. Well, whether you're on the top, like this pink one, they level off as you move out to the left, right? But still leveling off at the x-axis. On the bottom, when I had drawn that green one in there a minute ago, those level off at the x-axis, just coming from a different direction, but it still levels off at the x-axis. So I would say that's definitely true. And then it says for y greater than 0, y greater than 0. So we're talking about if you look at the top, right? If you look above the x-axis. So when you look at this part, all solutions are increasing. Well, yeah, look at the little tangent segments. Every single one of those little tangent segments has a positive slope, right? So the graph is increasing. So I think that one is true also. So it looks like 2 and 3. It looks like we're looking at letter D. Okay, now here's how these kinds of things, just in general, slope field might look in a free response. So we're given the differential equation, we're given the derivative. It says on the axis provided, sketch the slope field for the given differential equation. Now, on this one, they show a lot of little points. They would never make you actually graph that many little tangent segments. In fact, maybe I'll just kind of darken them. I think maybe they might have you do, how about we'll do these. We'll do the slopes at these points. And that's even a lot. They don't even usually make you do that many, but I'll just kind of enlarge it and say those are the ones we're going to do. So let's look for some patterns. Well, I know if x equals 0, it's going to be a little horizontal segment. So x equals 0 right in here, right? If y equals 0, it's going to be a vertical segment. So y equals 0 right there. If, let's go this way. If x and y are the same thing, then the whole thing equals 1, positive 1, right? So the slopes right here when y equals x, they're going to be a positive 1. And if x and y are the same number but opposite sign, so that would mean the points that fall right along here, right? Because isn't this where x and y are the same number but opposite sign? Those are going to have a slope of -1. So those are going to be going this direction, right? Slope of -1. And I could, you know, keep it going if I wanted to. We'll just go that far. What about, let's do some individual points. So what about like right over here at 2, 1? Well, that would be 2 over 1, so a slope of 2, right? Slope of 2. Down here would be 2, -1, so it's going to be a slope of -2, right? Up here where we're at, what is this, 1, 2, so that would be a 1/2, so that's somewhat flat. This is going to be a -1/2 over here. So I'm just kind of putting in the ordered pairs, right? At -2, 1, we're going to have -2. Right, +2 down here. And again, I'm just kind of gradually putting in these points. It's going to be something like this. Okay, doesn't have to be perfect, and like I said, they would never even have you do that many of them. Okay, and then really that's drawing the slope field. Look at letter B. Sketch a solution curve that passes through the point 0, 1. Well, here's the point 0, 1. Up here, it looks like the solution curves are going to do something like this. And again, if I had more points on there, I could get a better idea. So that's letter B. Find the particular solution, y equals f of x, to the differential equation. Okay, whenever it says find the particular solution, let me do that in a different color so I can kind of coordinate. Find the particular solution, that means they want you to find the actual equation, right? Well, when have we seen that phrase before? Haven't we seen that phrase when they wanted us to separate the variables, right? Separate the variables. So in other words, what they want us to do is they want us to take this original derivative, right? Separate the variables, so it's going to be y dy equals x dx, and then integrate both sides, right? So y squared over 2 equals x squared over 2 plus c. Notice I could go ahead and plug in my order pair if I want. My order pair is 0, 1, right? 0, 1. So if I plug in 0, 1, I'm going to get 1/2 equals 0 plus c, right? So c is 1/2. So y squared over 2 equals x squared over 2 plus 1/2. And how about we multiply through by 2? So really what I have is y squared equals x squared plus 1, or y equals plus or minus square root of x squared plus 1, right? Well, we've talked about this concept before. How do I know if they want the positive or the negative square root? Well, look up at my graph. Is that pink graph that I'm looking at up there going to be a positive y value or a negative y value? Well, it's a positive y value. So therefore, for that one, I'm going to put it in pink to match the pink curve. They want y equals positive square root of x squared plus 1, right? Whereas when you get to letter D, it says, okay, now how about we look at the solution curve that Look at the solution curve that goes through the point 0, -1. So what about if it's down here going through this one? Well, doesn't it look like it's going to be going this direction, right, if it's down here? And then notice letter E says find the particular solution for that differential equation. Well, it's going to be the same equation, but look at it. This time, if the y is negative, wouldn't that be the one where you want the positive square root? So this red one would be, would be the negative square root. Y equals negative square root, right? So the top was y equals positive square root. And then this bottom one will be y equals negative square root. So frequently on the free response on these slope field problems, they're going to be ones where you have to do this separation of variables. So if you look at the homework now, the rest of the homework, you still have a couple of multiple choice up here, and notice the first one's number 1 and number 2. Find the solution, right? We're talking about solution curve. That's what we just talked about. Number 3, also solution curve. That's what we just talked about. Number 4 actually can go either way. They're saying, hey, here's a derivative. So if you want, you can kind of look for the patterns and all of that, but it might be easier on this one. There's just the fact that we know that if the derivative is cosine, doesn't that mean that we know the original is going to be sine? Well, sine plus c, right? So it might be easier just to look at the shape of the graph and say, oh, I can tell which one of those is going to be the sine graph with some kind of a vertical transformation. And then, like I said, so this just kind of shows several different ways they might ask questions, and then it gives you 2 examples of specific free response questions. So like on the first free response question, this 2008 year, they had you actually draw a slope field and then find the particular solution, right? Meaning you're going to have to do separation of variables. But on the 2014 one, they didn't have you draw the slope field. They gave it to you, but they had you on part A to sketch the solution curve. It doesn't have to be exact, but you're sketching the solution curve. But notice still when you get down to letter C, it still says find the particular solution, which means you're going to have to separate the variables. So all of these slope field questions come down to that separation of variables type problem. So assignment is to finish this homework packet, and then I'll be back with you in class the next time, and we'll go over this. But please remember that if you have any questions, obviously, if you have too many questions, come in and ask me. Otherwise, we will go over this a little bit in class. Just compare your answers with the answers that I'll post for you, and then we'll do some practice multiple choice and free response related to slope field.